Hello, everyone. Welcome to the first ever Pulsar Summit Asia. My name is Jia. It's my great honor to be here with Penghui together to introduce a new feature in Pulsar 2.7. Penghui and me both work at the Simulative, and both are PMC members in Apache Pulsar. It has been 5 months since the last major release 2.6, and after 2 minor releases, finally the major release 2.7 comes. In this new release, we merged more than 200 commits, and thanks to all the contributors. As titled, the transaction developer preview is a major feature for Pulsar 2.7, and besides that, we have topic level policy, Oauth2 Authentication, Azure Offloader, native Protobuf Schema, and also Bookkeeper 2.12 included. Now let's give the control to Penghui to introduce more details about the transaction and the topic level policy. Hi, Penghui.
Yeah, okay, thanks, Jia. Hello, everyone here. Welcome to attend the Pulsar Summit. This is Penghui from Stream Native. Before we talking about the message, before we talking about the transaction, I will talking about the message deduplication first. Before 2.7.0, Pulsar can support the effectively one's semantics of the single petition by the dominant producer. It depends on the monotonically increasing sequence ID of new messages. The broker only accepts messages if the sequence ID of the new message is larger than the last produced. Just like the illustration shows, a message with sequence ID 5 can append to the petition successfully, but the message with sequence ID 3 will be treated as a duplicated message. So the message with sequence ID 3 will not be written twice. But as you can see, this mechanism can only work on a single petition. This is why we introduce transactions. We want the conflict exactly one's semantics. So what's different about the transactions? The transaction guarantee atomic multiple petition rights and multiple subscription acknowledges a read committed isolation. This means a bunch of messages in a transaction can be received from, produced to, and acknowledged by many petitions. All of the operations involved in a transaction succeed on file as a single unit, and all of the messages produced by producers with a transaction are available only for consumers until the transaction is committed. This enables new use cases with Pulsar, where a client can work with messages across multiple topics and ensure those messages will all be processed as a single unit. This will strengthen the message delivery semantics of Apache Pulsar and the processing guarantee and Pulsar functions. First of all, let's take a look at the new APIs that the transaction introduced. After that, I will introduce what Pulsar does behind each API one by one. First API, the new transaction, or we can say open a transaction. The second one is the producer sends a message with the open the transaction. And the third is the consumer receive messages from the topics and acknowledges message with open the transaction. And the last new API is the commit or abort the transaction. After commit or abort the transaction will be closed and no more operations can be done on this transaction. Yes, this is a new API that the transaction introduced and looks simple. Oh, sorry. Before we talking Before we take a deep dive into transaction APIs, there are some basic concepts of the transaction that should be introduced. This will greatly help us understand the transactions in Pulsar. The first one is the transaction ID. The transaction ID is the unique identifier of the transaction. It consists of 128 bits. The first 16 bits represent the transaction coordinator ID. This will be introduced later, and we reverse the 48 bits for expansibility, and the last 64 bits represent the local ID. The local ID is self-increasing in a transaction coordinator. The next one is the transaction metadata. Transaction metadata of a transaction contains the transaction ID, transaction status, open, committed, or aborted, and the produced partitions represent the topics that the producer produced messages with this transaction, and the acknowledged subscriptions represents the subscription that the consumers acknowledge the messages with this transaction. The next one is the transaction coordinator. The transaction coordinator will generate the new transaction IDs when the client opens a transaction, and the coordinator will maintain the whole life cycle of the transactions. The coordinator will record the transaction metadata so that when committing a transaction or aborting a transaction, the coordinator can finalize all the operations that happen on the transaction. If a transaction can be committed or aborted within a period of time, maybe the client crashes, the coordinator will guarantee the integrity of the transaction. Maybe someone worried about the transaction coordinator is a non-scalable centralized component. No, the transaction coordinator is a scalable component. The transaction coordinator assignment is achieved by the topic assignment mechanism in Pulsar. We just need to create a partition topic for the transaction coordinator assignment. If the partition 0 owned by if the partition 0 owned by broker 0, that means the coordinator with ID 0 also runs in broker 0. So the client just need to look up the partition 0 to find the specific coordinator. If you want to scale the transaction coordinator, you just need to add more brokers and more partitions for the transaction coordinator assignment topic. All of the transaction metadata changes will be persistent to the transaction log, so we can guarantee the durability of the transaction. The transaction log is essentially a topic. Each transaction coordinator will use a transaction log to record the transaction metadata changes. So after the broker crosses with some transaction coordinator, these transaction coordinators will be assigned to other brokers, and the transaction coordinator can restore the transactions from the transaction log. So the transaction is also high available. Now, let's take a look at what happens when the client opens a transaction. The first step, the client sends an open transaction request to the coordinator. The client can choose any coordinator currently in round robin pattern. The coordinator receives the open transaction request and generates a new transaction ID for the new transaction, and then append the event to the transaction log. And then the coordinator returns the transaction ID to the client. After these steps, congratulations, the transaction is opened and never lost. Next, we will start to introduce what the Pulsar does when the producer sends messages with a transaction. Before we start, we still have to introduce a new concept, transaction buffer. Why we need the transaction buffer? It's related to the read-committed isolation. The transaction buffer is to prevent the messages available for consumers before the transaction committed. The transaction buffer is achieved by the marker approach. All of the messages with a transaction and without the transaction will append to the partition. The difference is messages with a transaction will be available for reading until the transaction marker appends to the partition. So we can say this has not changed the processing or writing messages in Pulsar. There is no need to worry about if the message publishes with a transaction will affect the performance. Okay, the message acknowledges with a transaction is different from the current message acknowledges. The message acknowledges in Pulsar is the best effort operation. So the acknowledges might be lost when the broker crashes. It fires for at least once delivery semantics, but not works for exactly once semantics. So in 2.7, we introduced a pending acknowledged state for message acknowledged by consumers with transactions. Before the transaction committed, the acknowledged state of the message will be maintained as the pending acknowledged state and will be persistent to a specific topic to ensure the pending acknowledged state not be lost. After the transaction committed, the pending acknowledged state will change to acknowledged state, and the pending acknowledged state will be cleaned up until the acknowledged state is persistent well. This will guarantee the acknowledges not be lost. After the transaction aborted, the pending acknowledged state of the message will be cleaned up, and the message will be available for other consumers. The last API is to commit or abort the transaction. Through the above introduction, I think we can imagine what commit and abort are doing. In the first step, the client sends a commit or abort request to the transaction coordinator. The transaction coordinator persistent the transaction status change into the transaction log. The transaction coordinator finalized the transaction by the transaction metadata, such as commit the right to the partitions and commit acknowledgement to the subscriptions. The broker appends the commit marker to the transaction buffer and moves the pending acknowledged status to the acknowledged state. And now, all of the new transaction APIs are introduced, and hope this can help you to understand the transaction in Pulsar. Transactions in 2.7 is for developer preview, not ready for production yet. There are more works we need to complete in the next version, such as the chaos test, performance test, judgment test, observability, and some integrations such as offloader functions. The next new features in 2.7 is the topic level policy support. Previously, users of Pulsar can set the policy at the Pulsar broker level or namespace level. The broker configuration more like a default configuration. Users usually overwrite some policy by changing the namespace level policy. Some topics need to retain long-term data, but some are not. We also noticed some users creating more namespaces to deal with this scenario, but this will also bring more burden to topic management. So we complete the topic level policy at 2.7. Here are some examples to show how to use the topic level policy, such as the persistence policy, retention policy, or backlog quota. All of the policies that support overwrite at the namespace level now are also spotted at the topic level policy. Compaction policy, compaction policy enable or disable the message deduplication offload policy. Yeah, I won't list them one by one. You can try the Pulsar 2.7.0 as well. The biggest challenge of the topic level policy support is we don't want to put more burden on the keeper, but we need to store more policy data in the Pulsar cluster. Finally, we introduce a new powerful feature named the system topic, which can maintain all policy change events to achieve the topic level policy. Users don't have to worry about the topic level policy that will use a lot of metadata service resources. There is a internal system topic for its namespace named change events topic. All of the topic policies change will be persistent in this topic. So this is available for reading the topic change events by consumers or interactive query by Pulsar Circle. The broker maintains a topic policy catch, but not all topic policy catch will be maintained in the broker. The broker only maintains the topic policy that the topic is owned by the broker. So the topic policy catch is distributed in all brokers of the cluster. The broker restores the topic policy catch by replay the messages from the system topic. As the illustration shows, the topic policy catch of the topic 0 and topic 3 are maintained in the broker 0. The topic policy catch of topic 1 and topic 2 are maintained in broker 1. The broker eventually maintains the last version topic policy of the topic. The broker reads the message from the system topic. If not to reach the end of the system topic, the old version policy of the topic may be used by the broker. Only guarantees the eventual consistency here. It's not a big problem. The namespace level policy also guarantees the eventual consistency. The policy change event will not be kept in the system topic forever. We enable the topic compaction or the system topic so that the messages before the snapshot can be deleted safely. Therefore, we don't need to worry about the problem of too long time to restore the cache due to too many policy changes. Yeah, okay, this is all I shared today. If you are interested in trying out the new features, please download the Pulsar 2.7.0. Yeah, thanks.
Okay, thanks Penghui for the introduction of the transaction and topic level policy. Now I will follow Penghui to introduce some other major changes in the 2.7. The first change is related to the authentication. In the new release, we have added the added the Oauth2 authentication. With Oauth2 authentication, we could make it more. We could make the extension and integration with other environment more easily. And with Oauth2, now we have JSON Web Token and TLS and OpenZ, and also Kerberos supported in the Pulsar authentication. User could choose the best one for their use case. And another change is related to the offloader. In the new release, we have defined the offloader framework in the broker side. And based on this, we could add more configs and add more support with the current framework more easily. And based on this, we have Microsoft Azure supported. And now user could upload their Pulsar topics into AWS, into Microsoft, and also into the Google Cloud. Another feature is related to the cloud storage connector. This is open sourced in the Submitted GitHub repo, and with this we could use this connector to export the Pulsar topics into other cloud storage like the AWS S3 and the Google Cloud, and also Microsoft Azure. And besides this, we could also choose the format, like we could choose the Abort and JSON, and also Parquet format for the uploaded data, for the data that is exported from Pulsar to the cloud storage. For more detail, you could read the link in the page below. Another big feature is the native Protobuf schema supported. Before this change, we have Protobuf schema supported, but this Protobuf is based on the Abort, and so some of the prototype in Protobuf is not supported, and also the language is also limited. So after this native Protobuf schema supported, user could support more language and support more prototype in the Protobuf. Another big change is related to the Bookkeeper new release. And Apache Bookkeeper has graduated from Apache Foundation as a topic level project for 6 years now. And 2 weeks before, Bookkeeper 2.12 release has come out. And in this Pulsar new release, we also include the latest Bookkeeper release. And in this Bookkeeper release, we have several big changes also. The first is enable the explicit RAC by default on the reader side. And by this, we could fix the Pulsar Crystal query issue to get the last message. And also there is a BP41. By this change, we added the booking ID as the booking network address. This would make the bookkeeper access more easily. And we also support the Java 11 and switch Java 11 as the default Docker image. And in BP42, we have added the list and access of ledger metadata in the new API. And also we have added certificate role-based authentication. And that's all from the bookkeeper new releases. And I think that's all for all of this talk. Thanks, Penghui, and thanks everyone for attending.